Hello. In our last video, we discussed the introductory part of solutions where we discussed what is mixture. So there are two types of mixtures, homogeneous mixture and heterogeneous mixture. Also, we discussed that there is a classification of solutions, which is true solution, colloids, and suspensions. And this classification is on the basis of sizes of particles. So sizes of particles are very less in true solutions, slightly large in colloids, and very large particles in suspensions. So in this topic, we are going to discuss about true solutions, like the properties and chemical properties as well as physical properties of true solutions. So after that, we discussed capacity of solution to dissolve solute, in which we discussed definition of solubility and also the unit which is used to express the solubility. Now in this video, we are going to discuss factors affecting solubility. So there are total 3 factors, from which the first factor is nature of solute and solvent. Now, explaining this, I will say that generally compounds with similar chemical characters. Now this is very important point. Similar chemical characters, or you can say similar chemical properties, are readily soluble in each other than those with entirely different chemical characters or properties. Which means if solute and solvent have similar chemical properties, then the chances of solubility of that particular solution is high. If solute and solvent are of very much different chemical properties or very much different characters, you can say, then there will be slight difficulty in solubility of that particular solution. So here similar chemical property, which we can further say the principle which is like dissolves like. This principle is very important, and this we have already discussed in standard 10th. So like dissolves like is very important principle. As I said just now, similar chemical properties tend to dissolve more readily. Nothing but like dissolves like. I will like to elaborate this. So if polar solute and polar solvent is there, both are polar in nature, then the solubility of these two will be very high. But if solute and solvent are different, so suppose one is polar and other is non-polar, then the solubility will decrease. So this was the first factor. Second factor, which is effect of temperature. Now to explain this point, I will write very important statement, which is solubility of any solution is directly proportional to temperature. Now what does this mean, directly proportional? If temperature increases, solubility also increases. If temperature decreases, solubility also decreases. So this means solubility is directly proportional to temperature. For example, if I take container A, which is having water, which is having cold water, and if I am adding sugar into it, and container B, which is having very much hot or boiling water, you can say, boiling water, and again I add same amount of sugar in it. Now the solubility for this container B will be high, as the temperature of this container or the temperature of this water is also high. So solubility of sugar into this hot boiling water will be high as compared to solubility of the sugar into this cold water. We will move further. We are having third factor, which is effect of pressure. Just now we discussed effect of temperature. Now we will discuss effect of pressure. Now, again, I can say the statement, which is very important statement, solubility of any substance or solution is directly proportional to pressure. Okay. So now this factor is important for gaseous substances. Why it is so? Because pressure has no effect on solubilities of solids and liquids, as they are incompressible. As we already know, solids and liquids are incompressible, or we can say they are very, very, very less compressible. So we can't say anything in case of solids and liquids, but in case of liquid, liquid mixtures or gaseous solutions or gaseous mixtures, we can say that solubility of that gaseous mixture is directly proportional to the pressure of that gases or the gas. Okay, so solubility where so this I can write is solubility S is directly proportional to P and I have said directly proportional, which means if solubility increases, pressure increases. That is, pressure increases, solubility also increases. If pressure decreases, solubility also decreases. And to equate this equation, I will write S is equal to KH into P, where KH is nothing but the proportionality constant. As we know, we take proportionality constants when equating any equation. So proportionality constant is there, which is KH, also called as Henry's constant. So Henry's law is this: solubility of any gaseous substances is directly proportional to pressure, and we further can say that S is equal to KH into P, where KH is nothing but proportionality constant, also called as Henry's constant. Thank you.